so much math work to do.
I heard Cassie's on the second floor studying. Do you want to go?
Yeah, let's go. Right. Hey Cass, can we study with you?
Yeah, sure. Here's my review. We need to know rock cycle, continental drift, plate movement, and mountain building.
Okay, let's start with the 3 types of rocks.
Sedimentary rocks are formed when layers of eroded sediment are compressed for many millions of years. There are 3 types of sedimentary rock: chemical, clastic, and biogenic.
Clastic is cemented fragments of rock. Biogenic sedimentary rock contains organic materials. Chemical is a rock formed through chemical reaction, such as water evaporating. Igneous rocks are formed when lava solidifies. There are 2 types of igneous rock: intrusive, which is when the lava solidifies below the Earth's surface, and extrusive, when lava solidifies above the Earth's surface. Metamorphic rocks are any type of rock changes when put through extreme heat and pressure. Most metamorphic rocks are made through mountain building processes.
Guys, who remembers all of the rock cycle?
I do. I actually remember.
The rock cycle explains how the 3 types of rocks, metamorphic, sedimentary, and igneous, are made. The rock cycle receives energy from both above and below. When extrusive igneous rocks are exposed to weathering, erosion, transportation, decomposition, burial, and lithification, the result is sedimentary rock, which can become extrusive igneous rock again through melting. Sedimentary rock can also become metamorphic rock if put through the process of metamorphism. Both results occur within the lithosphere. Metamorphic rock can reach the Earth's surface through uplift due to mountain building. Like sedimentary rock, intrusive igneous rock can become metamorphic rock through metamorphism. Intrusive igneous rock can also reach the Earth's surface in one of 2 ways, either eruption of magma or uplift due to mountain building. Intrusive igneous rock is created through the melting of sedimentary rock, then the intrusion of magma. That's where convection currents come in. Convection currents work when magma moves from warm regions to cool regions. The magma closest to the core heats up, then rises towards the surface, then cools to fall towards the core, and the cycle is repeated over and over again. Since tectonic plates lie in the moving magma, they move as a result of convection currents.
Oh, okay, I get it. So the next thing we have to cover is mountain building. It's folding, faulting, and what's the other one?
Well, I know folding is a type of plate movement where the rock literally folds up to create mountains. It usually happens in sedimentary rock because it's more flexible than the other 2 types.
Wait, I still don't get it. Oh, here's a video Caps told us about. Okay, wait, so like, what are we doing?
What's happening? So this is like a taste test, right?
Our purpose is to show how pressures in the earth can bend and break rocks as mountains are formed. This experiment will simulate how plate tectonics cause the formations of mountains.
Okay, so with your materials, you're gonna basically create how mountains are formed.
Really?
Okay, so our purpose here is to simulate how forces acting on land creates mountains.
Excellent.
Materials. For this experiment, you need a transparent box, a piece of cardboard, dry sand, flour, and a dessert spoon.
So what do you guys think is gonna happen when you like add this stuff all together?
I don't really care, honestly.
I kind of thought we were baking at first, but then I saw the sand, so
You
I
can
don't
still
really
make
know.
the sand.
Step 1. Add alternating layers of sand and flour until the box is halfway full.
Okay, yeah, I'm so excited. It's gonna be fun.
This is going on BuzzFeed, right?
And then now put your flour. Not more. You just spilled it everywhere. No, it sounds fun.
Geography is entertainment.
Snow? Is that what it symbolizes?
It's white.
So now we just put sand over it? Okay. More, I think. That took a long time. Okay. What now?
Step 2. Cut the cardboard so that it makes a close-fitting vertical partition in the box.
Okay, so now we want you guys to cut the cardboard into strips. Thick, long strips. That. Like this? Yeah. Okay. So first, what do you think is going to happen?
Hypothesis. We think that the force of the cardboard pushing against the sand and flour will cause the layers to bend up. We don't think the layers will mix. Instead, we think they will all bend at the same rate.
So I think the force of the cardboard will push onto the same, causing an uplift, which will make a mountain.
Honestly, I think it'll just make a mess.
Step 3. Place the cardboard at one end of the box. Grip the piece of cardboard and move it slowly and gently towards the other end of the box.
Okay, so now we want you guys to push the cardboard towards the middle. We better be getting paid for this. So, what did you guys notice?
Observations. We saw that pushing the cardboard caused the layers to bend and rise up, similar to the way plate tectonics causes mountains to form.
Our prediction was right.
So like, as you can see, there was an uplift. Like you can see like all the layers that kind of formed like a mountain.
I noticed that the sand moved up.
Well, she's really ugly. I don't know if you noticed, but like...
Conclusion. In this experiment, the layers of sand and flour represented the sedimentary rock. The cardboard represented a plate on the Earth's surface, and when we pushed the cardboard, we were simulating the convection currents putting pressure on the Earth's plates. As we pushed the cardboard to make the layers bend, we were creating mountains, the same way folding creates mountains. Folding is a type of plate movement caused by the compression of rock layers. This happens along converging plate boundaries. When two plates are colliding, the forces pushing against the plates cause the land in between to bend up. This is most common in sedimentary rock since it is the most flexible compared to igneous or metamorphic rock. Folding creates highlands and lowlands. These highlands are called anticlines and the lowlands are called synclines.
Thanks guys, that was great. You can go.
Thank you for this very educational experience. I would feel so
That video was pretty good.
Yeah, I think I get it now. We also have to know faulting, which is the other way landforms are created.
Oh, I know this one. Faulting occurs along plate boundaries, and there's three types of faults. There's converging, diverging, and transform, also known as strike slip.
Converging plate boundaries are when two plates are moving towards each other. The two types of converging plate boundaries are collision and subduction.
A collision zone is where two plates hit each other and both push up to create mountains. A subduction zone is when two plates collide and the plate less dense slides under the more dense plate.
There is only one type of diverging plate boundaries. This is when two plates are moving apart, creating a ridge. An example of this is Iceland, where the North American and the Eurasian plates are moving apart.
The last type of plate movement is transformation fault, which is when two plates slide against each other. An example of this is the San Andreas Fault on the coast of California, where the Pacific plate is rubbing against the North American plate.
But guys, what are grabens and horsts?
They are highlands and lowlands created by faulting. Grabens are formed when two plates are sliding apart, causing the land in between to sink down. Grabens are also known as rift valleys.
Horsts are also formed through faulting. They are a result of two plates pushing against each other, causing the land in the middle to uplift. This is how block mountains are formed.
Wow, okay, I think I actually get this.
Same here. The test shouldn't be too bad after we've done all this study.
Yeah, I mean, like, we've done everything we could.
Yeah, alright guys, let's go home now then.